y, didn't we? Use y yesterday? Okay. This will be more functionally based. When we talked about that thing right there represents your dependent variable anyway, which is your y. So if we're looking at a function like that, what is the difference between an exponential growth function, where something grows exponentially real fast, or an exponential decay function, where a decay goes down really quickly? What makes the difference? Because both of them, we use that formula. So we had to define terms to make a difference. Sam, what's the difference?
I think A and B are positive.
Okay, good. A and B must be positive. That is a true statement for a growth. So A and B are positive. That's true. What else we say, John?
Well, is this just for positive?
Oh, just for growth.
Well, growth, you have the...
Okay, what do you have for decay then?
For decay, I know that B is a negative. Or it's not a negative. It's greater than 0 but less than 1, so it's a fraction.
Okay, good. B must be a fraction. That is exactly right. So B must be a fraction of some kind for it to be decay. That is correct. So B over here must be what? How can I describe B over here? Brandon?
Greater than 0.
Okay, it has to be greater than 0. That's positive. Is this greater than 0?
Yes.
So how do I differentiate this from this? Ben?
Growth it's greater than 1.
Yes, let's say that. B must be greater than 1. Let's do that, okay? If we want to add this positive part, then we would say... well, B must be greater than 1. That's going to be positive. Yes, ma'am? Excellent. Okay, good. So B must be greater than or equal to 1. That would be a growth. Over here, B must be a fraction. So we describe it as 0 is less than B, which is less than 1. So same formula for both of these. We just have to find what B is for both of them. In this case, y is going to be some kind of a fraction raised to an exponent, a variable exponent. And we talked about yesterday, if we squared 1/2, right, we'd get what? What's the square root? Yeah, 1/4, okay. And if we multiplied it by a half again, we get 1/8, and then 1/16, 1/32. Okay, we get a smaller, smaller, smaller fraction, right? So that's why this is going down, because my dependent variable, my y value, goes down on my exponential graph, right? Okay, goes like that. In a growth function, this is going to be a positive number bigger than 1, so let's just take a 2. So 2 times 2 is 4. 2 times 2 times 2 is 8. Multiply that by 2 again, I get 16. Multiply that again, I get 32. Multiply 2 times 32, and I get 64. So if I had something like this, y equals 2 to the x, this number is going to get bigger and bigger and bigger very quickly, so I end up with a graph that looks like that. That's exponential growth. That's exponential decay. Okay? Now, then we talked about yesterday this little letter here, letter E, being a common number that comes up in creation. We create things, particularly in we can use it in compound interest, which we talked about. We'll look at that in just a minute. And also decay, when things grow or decay over time, this letter comes up a lot. What was it, 2.17, something like that, in your books or something? We had that E. Anybody see what it is in your book? 718. Okay. 718, oh, right, keeps going, okay? And so this is a number that comes up in different places quite often, and we call it the letter E. They often use a formula here for decay or growth with the base of an E. So how in the world, if this E is a 2.718, how can I make E into a fraction by just affecting the exponent right there? That would be a fraction by affecting the exponent. Jillian? Yeah, this exponent here is going to have to be a negative of some kind. So this is another decay formula, all right? You need to recognize if I have y equals e to the negative exponent, that's going to be a decay formula. If I have y equals e to the x of some kind over here, then this would be a growth formula, All right. I would like you to do these classwork problems, please. Would you please do on page 248? Looking at these and telling me, are they growth or decay functions? You're going to do 32 or 38 even. And on page 249, they're going to give you a growth function. I want you to plug numbers into it and solve it on your calculator. You're going to do number 55. So just read that problem. You work those. Look around and look at your homework. And we will get some of this up on the board. You do put them. Just write them down. What you like. 2, 3, 5, and 7 on the board. Sorry. Homework. Do 9 and did you figure out 15? How did that work?
Yeah,
I said 15
was yeah, this.
Okay. Show me how you figure that out. So put 9 and 15. Okay. Homework. Okay. Yes, Sam?
Are we supposed to simplify this?
You can't simplify that anymore. Just leave it right there. You're asking me, yes, leave ease in your answer. That's what you're asking me. Okay. Leave ease in your answer. Thank you for asking.
I don't know how this.
All you're going to do is write that down, and you're going to plug in what we need. So, what does X stand for? That's right. So you're going to put that in there, and you're going to run that through your calculator, find out what y equals. Can you write that as a board, please, so we see what you're plugging in? Okay, what are you working on? Okay, those are simple.
See what you have there.
What did you get there, Brian?
895. Yeah, 895.
You're exactly right. Nice job. Why don't you go ahead and, since you're out of time right now, I'm going to let you do your homework and write the columns down with it. Work on that right now, write the columns down with it. And rework. You got it right. to 1. All right, let's look at your homework from last night. And
What number thing started with?
we started with page 234, numbers 37A and B, and she is finishing that up. Let's go on to 247, numbers 3 through 11 odd, if you did any of those, please. 247, 3 to 11 odd, number 3, 4, 5, 7. Jackson?
Okay. So I had E cubed times E4. We have like bases, we had exponents, so I put E to the 7th. Number 5, I had 2E to the 3rd x power, and I was raising that. I was raising that to 3rd. So I had to raise 2, and then cube the 2, and then multiply the 9, 3, raise whatever you multiply. And got 2 cubed E9x, and then I simplified the 2. 8 E9x.
Okay, so how do I say that, sir?
8 E 9x power.
To the 9x power. That's exactly right. Good. Don't just say E9x, okay? E to the 9x power. Excellent. Keep
And
going.
then down here I had 3e to the 5x power raised to -1. So I raised all of the whatever bases or quantities. And then I got 3 to the -1 power, e to the -5x power, and then I inverted the bases and changed the exponent to negative. And got 1 over 3 times e to the 5x power.
And he is correct. Raise your hand if you got number 7. Raise your hand. Excellent. Well done. Great. Okay. 9. Whoa, Jackson.
What I do?
Got a question.
It's
Madison.
Okay.
Okay, I got -3 over e to the 5th x. Why is 3 in the denominator?
Negative exponent.
But you,
The base was the
-3 doesn't have an exponent.
It doesn't
Okay, look at his
look like-
problem that he has written up there. He actually did write the problem down. So that -1 exponent, point to the -1 exponent, please. What is the base of the -1 exponent, Madison?
3?
3 and e to the 5x, both of them. Because they're in parentheses, that -1 affects both of them.
So you just don't multiply like it being -3
Excellent question. What does a negative exponent tell me to do, Madison?
invert the base and change the sign of it.
Does that negative exponent ever tell me to change the sign of the base?
No.
That's what you did, though, right?
Mm-hmm.
You made -3. So what a negative exponent tells me to do? It tells me to invert the base. So whereas it is 3 to the -1, this 3 now is in the numerator, it's going to go to the denominator. Okay? Follow the rules. Next one.
I had the square root of 9e to the 6th. So took the square root of 9, got 3. And then I divided the 6 into 2 and got e to the 6th.
Excellent job. 15.
I had 4e from 2x. Binomial cubed.
Quantity cubed. Okay.
Quantity cubed. So since it had parentheses, it means it cubes everything. So I got 4 cubed.
Good.
And then e to the 6x, because you raise power to power, you multiply. And I cubed 4 and got 64 e to 6x power, which equals c.
And that's exactly right. Problems, questions? All right. And then that takes us to, apparently I didn't put 19 to 23 at the board. Why did I do that? I don't know. Turn a page, number 19. Oh, I know. Okay. Plug these into your calculator. Number 19. John, what did you get for 19?
My answer was 20.09.
Okay. It does not say what to round these off to, so that's kind of an interesting
I
thing.
rounded off just to the cent.
Okay. Well, these aren't dollars and
Yeah,
cents.
sorry,
so,
the 10.
to the, well,
Or the 100th power.
there we go. That's
Whatever it
correct.
is.
Okay. How about 21? What do you have? Madison, question?
Yes.
Okay.
Number 11, what is the difference between E and EX? over e to x. What's the difference between e and e to x?
We did number 11 last night? Did we just have that up here?
Yeah, we got to do number one.
Okay, I don't know that I actually saw that, so I may have said the wrong thing. What's the difference between here? Because you're asking me to subtract the exponents, is that what you're doing? Okay. I think I may have made, I don't think I drew attention to this, and so I may have accepted an answer that was incorrect. I'm not exactly sure. What happens to the 3, class? Anything? Nothing happens to the 3, right? You can divide it by 1, you're going to get a 3. It's going to be in the numerator. It won't change. How do I divide like basis, class?
Subtract.
Subtract the exponents, right? What's the exponent of that one?
Nothing.
It's a 1. What's the exponent of that one?
X.
It's also a 1. Or no, it's x.
It's an x. All right, so actually all I have there is a 1 minus x. Can I subtract those two? No, I actually can't. So all I can do there is go e to the 1 minus x. And I actually have to leave that denominator, that exponent just like that. Okay, sorry I missed that a while ago. Rachel.
How do you do number 19?
Okay, hold on, I'm going to go to 19 here in just a second. Questions on that one? Sorry I made that confusing. John.
But isn't there technically a negative exponent?
Isn't there technically a negative exponent there? I can't tell because I have no idea what x is. So if this is 0.5, then this might be a positive fraction. So I really don't know, so I'm just going to leave it just like that.
Well, what I did is x would have been negative, but
Yeah, but I don't know if the whole
Yeah, I know
thing
what
would
you
be
mean.
negative.
Yeah.
Okay? So we might have to leave exponent just like that. Same question on this one? Okay, you have another question? On what number?
23.
Okay, let's go to 19 first of all. Did you learn how to plug in your calculator? Okay, so make sure you can do that. Let's go on to 21. What answer you get for 21, Travis?
I got 9.025.
Make sure you can plug these into your calculator and you're getting these. And then how about 23? Brian, what'd you get?
What are we doing right now?
We're finishing up the homework, I believe. Number 23?
Yeah, it's a
Oh,
lot.
0.082.
23. I did not get that.
Ew.
Madison?
0.67.
0.67. You got a negative exponent in there. You do have to put parentheses probably if you're going to use a caret and raise it to that power. You better use parentheses around it. Make sure you can do that in your calculator. Very important. Now, questions. Is that the one you had a question on, Sam? Can you get it now, or you still have a question?
What was the answer?
0.670.
Okay, I got it.
All right, good. Make sure you can use your calculator. Any questions or problems with those? Okay, excellent. Jillian, it's you.
I had to use the formula A equals 391 plus R of N to 23 power. So I plugged everything in, I changed the percent to decimal, and then it was over quarterly, so it was 4 in the denominator and in the exponent. And I multiplied out and all that, and then I got a final answer of $2,479.38.
And she's exactly right there. Raise your hand if you got that. How we do? Okay, any problems, questions on how to plug things in? First of all, what she has written up there for her formula. Any questions on that? What, okay, yes, sir?
Why is it the 4 times 4?
Is n times t. N is the number of compounding per year. It's quarterly, so it's 4 times per year. T is for how many years? And so it says here, how many years, class? 37, 4 years. So 4 times 4. That makes sense? Okay? And then once you have her second level, you just have to be able to plug it into your calculator. Any questions or problems? All right, last one. B?
I did the same thing as up there, and I got an answer of $2,406.98.
And she is correct there. Any problems or questions with any of that? Okay? All right, now we get to the fun part. Did you all hear what we're learning today? Madison, were you in here when I said what we're learning? Oh, it's going to be so good.
Logarithms.
Oh, classwork, I forgot. Yes, we're learning about logarithms today. It's going to be so fun, but you have to wait one more second until we finish the classwork problems. So 32 to 38, you simply have to know if we are doing decay or the other type problem. Number 32, what kind is that, Brian?
Decay.
Number 32 is decay. How do you know that?
Because it's a fraction.
Actually, that's not a fraction. Because what do you have to look at there? John, what do we have for number 32?
I have growth.
It is growth. Why is it growth?
Well, because the exponent there, b4, and
Okay, with the exponent is positive. What's the base? What is b in this one, class? E. So E is a positive and it's not a fraction. It's 2.7, blah, blah, blah. So therefore, we will have a growth there on that one. How about 34? What is that one, Anna? That one's growth. How about 36? What is that one, Sam? Function of x equals e to the 3x. Rachel? It is growth because we have e, so it's going to be greater than 1. And 3x is positive. And number 38, Travis, what do you have?
That one's decay.
That one's decay. How did you know that?
It has a negative
It has a negative what?
exponent.
Negative exponent. That is correct. Okay, so we have a negative exponent. All right, then let's go to your spiral, and let's talk about, don't put logarithms down yet. You can put 4.4 as the lesson in your book, 4.4, and let's title it Exponential Equations. Yes, sir? We did. We put this one at the board. I'm so excited about it. I just want to get to them so much. All right, on tell me what you did here with this one exponential. I do want you to know how to do these problems, by the way. They gave you the formula. All you have to do is be able to substitute something in and get it. So please make sure you understand that. Tell us what happens here.
So they gave us the formula already. The only thing we're missing is x. So x.
Hold on just a second. Who finished this problem? Raise your hand. Okay. Ben, would you please read the problem for us, please? Everybody's on page 249. I want you to understand the problem. Read about camera phones, Ben.
The number of camera phones globally can be modeled by the function y equals 1.28e to the 1.31x power, where x is the number of years since 1997, and y is the number of camera phones shipped in millions.
Stop right there. So we have a formula here that is what? Exponential growth or exponential decay? Class? Growth. The number of camera phones shipped globally since 1997. Do you think that grew exponentially?
Yes.
Okay, yes. Everybody's got a camera phone nowadays. Okay? So this is an exponential growth, and I want you to understand what it's telling us. The y that this is going to spit out is how many millions of phones have been shipped. All right? In that year. Depending on how many years from 1997, where x is the number of years since 1997. What did you do?
Okay, so I needed to find out the number of years first. I took from 1997 to 2002, which is 5 years. So I just plugged that in for x. So first I had to multiply 1.31 times 5. And I basically just put that on top of it. And got 895. But there was a decimal. But you can't-
There was. She's rounded that off. And this is actually 895 million camera phones were shipped in that year, in 2002. Okay, everybody understand the concepts? Understand how to use that? You didn't have to know anything in advance for that. All you're doing is reading what it says, realize that it's been 5 years since 1997, and plug it in. Okay? All right, let's go to your spiral, please. And write down for the first thing, we're going to write here. Exponential equations is what we're going to start with. Put 4.4 exponential equations. I'm going to teach you a few things before we get to the book. So you will need to write a few things down here. We're going to start with exponential equations. Exponential equations. Now we talked about exponential growth and exponential decay, right? We had those. Y equals a x squared or something like that. Actually we said y equals ab to the x, something like that, okay? An exponential equation simply is when your variable is an exponent. Okay, so I want you to know that when your variable is an exponent, that would be an exponential equation. Based on that, then, I want to know a couple of things about exponential equations. First of all, how do we say it? Well, if I were going to ask this question, what does it mean? It means, to what power do we raise 2 to get 8? To what power do we raise 2 to get 8? I want you to know how to ask these questions. So this is, to what power do we raise 2 to get 8? You all can tell me that answer right now, right? What is it, class? 3. Okay, so you can just look at this one and tell me the answer, of course. How do we solve them when they get a little bit more difficult? This is how you solve them. Solving exponential equations. We're going to set a base to an exponent equals a base to an exponent on both sides of the equal sign. Get a base to the exponent equals base to the exponent. The little thing that we're going to say, if you've noticed, I'm really big on memorizing little quips of how to say things or how to do things. This is what we're going to say. Get the same base on both sides. Get the same base on both sides. Write that down, and then I'll explain what we have here. Okay, get the same base on both sides. What it means, then, is if I have b to the x, notice I've got the same base on both sides of my equal sign. So if b to the x equals b to the y, so I've got a base raised to the power on the left side, base raised to the power on the right side, then my two exponents must be equal to each other. So x will be y. All right? For instance, if I did this problem over here, 3 to the x equals 81. If I did this problem right here, 3 to the x equals 81, I want to get the same base on both sides. Can I rewrite both sides so I have the same base? Well, I can't do anything with this one. It's just going to be 3 to the x. Is there any way to rewrite 81 with this base? How could I rewrite 81 with this base? This would be something raised to a power over here. What would it be? John?
Well, I mean, especially with the 81, you know that 9 goes into it twice.
Okay, but I want to use this.
I know, and 3 goes into 9 twice.
So, well, how can I rewrite 81 as 3 with 3 as a base?
Well, you have 9 times 9, and there's 3 3 each 9, so it'd be 3 to the 6th power.
Brian?
3 to the 4th power.
3 to the 4th. There's 2 3s in every 9. So therefore it's going to be 3 to the 4th. If I can rewrite both sides with the same base, then I know that my exponents are equal. I've written these with both sides with the same base, so therefore I know my exponents are equal, and x equals 4. Yes, ma'am?
Is there like a quicker way to finding out, like, 3 times what's 80, what is what equals 81? Like, if you have huge numbers.
Well, you're going to have to think through, if I have to rewrite this as a base with a 3, how can I rewrite 81 with a base as a 3? 3 goes in there how many times? And you're going to have to think through that. Okay, we'll get better at it. How about 4x? 4 to the x equals 1/16. You see the correlation between 4 and 16, right? We could do that. But how in the world, how can I get this 16 out of the denominator? Is there anything that I know that gets things out of denominators and puts them up in the numerator? Jillian?
Negative exponents.
Oh, a negative exponent. Yeah. So I could get this 16 up here, but when I move the 16 up here, what do I have to do to the exponent, class? Change the sign. So therefore, this 4 to the x could be 16 to the what?
1.
Negative 1. Yeah. Okay, now stay with me here for just a second. I still haven't changed. You know what would have been easier? Hold on just a second. Hold on a second. Everybody sees this could be written with a base of a 4, right? rewrite 16 with a base of 4, what's going to be, class? 4 squared. Okay? Now, how do I get this 4 up here into the numerator, class?
-2.
Change the sign of the exponent, right? So now I have 4 to the -2. Have I rewritten with the same base on both sides? That's what that said I was do. And if I rewrite with the same base on both sides, what do I know is also true? Sam?
X equals
The exponents are equal. If the bases are equal here, the exponents have to be equal, therefore x equals -2. There's my answer. You see how that works? Okay? So that's how we solve exponential equations. Yes, ma'am?
So if the bases are equal, the exponents are?
Exactly right. That's exactly right. If I can rewrite an equation so I have the same base on both sides, my exponents have to be equal. They have to be. Sydney?
For the 4x equals 16 negative 1 exponent, would that also be the correct answer, or would it have to be you?
Well, I have not yet written it with the same base on both sides, right? You're going to watch this. Is kind of interesting. Can I rewrite 16 with this base? What would it be, class? 4 squared. I'm going to go ahead and put it in parentheses. This looks ugly over here, right? I have a power raised to a power. How can I simplify this? Multiply my exponents, right? Power to raise power. So now I have 4x equals 4 to the what, class? -2. So you can do it either way. Okay? If I have the same base, then my exponents have to be equal to each other. All right, so therefore, I would like you to do a couple of problems. Please, would you work those problems right there? 1 through 8. I want you to rewrite them so that you have the same base on both sides. If you have the same base on both sides, you know your exponents are going to be equal. What?
With that problem, when you invert them, when you have would you invert negative or the one on top at all?
The 1?
Yeah, I think you would, but 4 equals 4.
No. But every numerator has a 1 in the denominator.
Right, I know that.
Okay.
Because I'm saying if you would invert it, you'd have a negative exponent on that as well. I mean, you can simplify it to 16.
Well, 1, I don't care if you have negative exponent 1 or not, it doesn't matter. 1 raised to any power is 1. Let's work a few more and see what you have. All right, what about 4 to the x equals 256? Anybody figure out how to write that with the same base on both sides? Sydney?
4 to the 4th exponent, or
Well, this side's going to stay 4 to the x. What is this? What did you say?
4 to the 4th.
Excellent. Yeah, great. Okay. So she found out 4 to the 4th is 256. So therefore, if I have the same base on both sides, what else is true, class? Exponents are equal, so x equals 4. And I will do number 2 with you, and then I'll let you work on your own. But number 2, we have 2 to the x equals 1 over 32. Let's go ahead and change it into the same base, first of all. Can I do something to 32 to get it to the base of 2? Megan?
I don't know how to do these very well.
Well, all I'm doing is rewriting 32 with a base of 2. 2 to the what power equals 32? Okay, we ought to know
16.
these. What's that?
16. 16 times 2 is 32.
Well, 2 times 16, yes.
I don't know.
What's 2 squared, class?
4.
What's 2 cubed?
8.
2 cubed is 8. What's 2 to the 4th?
16.
16. What's 2 to the 5th?
32.
What's 2 to the 6th?
64.
You need to know those. Okay? So you need to get familiar enough with them that you know those. Those should be pretty common to us. Okay? So 32, can I rewrite as a base raised to power? Madison?
Yes.
What do we?
Well, we reduce 2 to the power.
2 to the what?
5th power.
2 to the 5th. Okay. So it's going to be that. But that's still not exactly right yet. So Jillian, how can I make this to the same base on both sides? Okay, good. So how do I rewrite this one?
So to you, the -5.
2 to the negative 5. And therefore, what is x equal to?
Negative 5.
X equals negative 5. Once I can rewrite them the same base on both sides, then my exponents are equal. Okay? Why don't you go ahead and work then 3, 4, 5, and 6. John, go to number 3 at the board. Number 4 at the board. Rachel, what's your number 4? Number 5, Jordan. Number 6, Brian. Number 8, Brandon, please. Which one?
Just the way to write it on the board.
Number 4 is a typing error, please. This should be 5 to the x plus 1. It'll make much more sense. Number 4 should be 5 to the x plus 1 equals 25. Please correct that. Sorry about that.
Yeah, I have 2 questions. Okay, can you read this sentence?
No, I wonder what x is.
So, how do you...
You change from negative x. What do you do?
Oh yeah, she's not gonna be able to see the other. Can you do this? Can you help me?
Help you.
No.
Thank you.
Both sides.
Thank you so much. Hoping this friend.
I'm still.
And multiply things both sides. Yeah. So can I leave the left-hand side exactly like it is. Change the right-hand side. Have a base.
So look,
Leave the left-hand side exactly like it is. To get the same base. Then put your 2 exponents equal.
That's what,
3 to the what equals that?
3 squared.
Yeah, so you do 1 over 3 squared, you can have the base and negative. I think it is.
On number 3
3 to the negative x.
and 5,
No, I did
leave the
backwards.
left-hand side exactly as it is.
So that's the same thing. That's it.
On number 3 and 5, leave the left-hand side exactly as it is. Change the right-hand side to have the base that the left-hand side has. If you have the same bases, then what do we know about the exponents, Jordan? So set them equal and solve for x.
I don't know how to do these. That doesn't make sense.
Set your exponents equal and solve. And that's it. It's actually pretty simple. Okay, you're right so far. He's leading you in the right direction. So now, how do you get this 3 out of a denominator?
You make a negative.
You make an exponent negative. So put equal sign over here. And how would I rewrite that? That's exactly right. Put your left-hand side. You have the same base on both sides. What does that mean? But that's not what you have for the exponent on the left side. What's the exponent on the left side?
Negative x.
Then put a negative x there. Okay. Now solve for x.
This is so weird. Dude, 5 and negative 1.
Yeah, you're making this harder than it is. Do you have the same base on both sides? Do you have the same base on both sides? Oh. Number 7.